Something that comes up more and more in recent years is about graph of the function. And in this case, it's combined with the knowledge about calculus. So let's see. The diagram below shows the curve y equal p. So we can see that's a cubic function, and line y equal L. So that's a linear function. Okay. What do we need to do with that? There are two values of x in the domain 0 and 10. So two values of x in this graph for which, and here we have equation written. So how do we understand? First thing you will be thinking, well, derivative of cubic function is the same as a derivative of linear function. Okay, but we don't have the functions, therefore we cannot create derivative, therefore we cannot equal them. Therefore, how are we going to solve it? And then they are saying use the information in the diagram to estimate those two values of x as accurately as you can. Show your work on the diagram. Okay, now the idea that we are using, so don't forget that's very often in your exam that they are writing or they are giving to you derivative. But the knowledge you are applying that the value of derivative at specific point is the same as value of the slope of that function. That's the idea that we are actually using. So you can read it in a little bit different way, that the slope of P is the same as the slope of L. Now, slope of L means what? This is a linear function, so this line itself is the slope, isn't it? So if I want to have the line that has the same slope and find where is that at Q, I need to basically have a parallel lines. Let's get parallel lines here. So I'm just going to draw that over, and then I'm going to move. Okay, let's move. So that's what you do. You use your line and you draw. Okay, and then let's clone that. And oops. Oh, that's not what we want to do. And we go again. We are looking for a place where that line will touch our cubic function. That's basically what I'm looking for. Why am I looking for that? Because that means that is like a tangent. Oh, I can't move this. This is like that line becomes, it is a tangent, isn't it? Because cubic equation at every point is going to have a different slope. So I am looking, therefore I'm drawing a tangent to find where is that point going to be. So I know that line didn't want to move, but my estimate should be, that should be one value of x. And this one here, that should be a little bit more further. That should be my second value of x. Now, it is an estimate. So here, what we should have, the value of x should be 2.2. And here, the value of x should be around 6.8. Like I'm saying, it is an estimate. So if you have a little bit more or a little bit less, you are still good because it is an estimate. But the main idea, the main knowledge that is applied here is the fact that they are giving us a derivative, but the way we read that is that the slope of cubic function is the same as the slope of linear function. That's the knowledge, that's how we have to read it, and we are applying the knowledge that the value of derivative at a specific point is the value of the slope of that function at that point. That's the knowledge that we are applying here. And yes, it wasn't easy to see that as an answer here.